Hi, James Whiffen here for CG Tuts, and in this first part of a two-part tutorial series, we'll be taking this live action footage and putting in some CG glass which will receive reflections from the live action footage as well as an HDR image-based lighting setup, and it will also refract the live action footage as well. And we'll also be looking at how we can get these great looking caustic patterns to appear. And in the second part of the series over at AE Tuts, we'll be looking at how we can composite all our passes together inside of Nuke, and also how we can refract 2D elements such as the Tuts Plus logos. Okay, here in PFTrack, step 1 is to match move our scene. And before we do, let's undistort this footage. It has a small amount of barrel distortion, and I want to make the match move as accurate as possible. So I happen to know that my camera's distortion is 0.041, and you can calculate that by using these measurement lines and hitting solve. And once we've done that, let's add an auto track in here. And it's a good idea to sometimes enhance the footage so it makes tracking a bit easier. I'll increase the contrast and then maybe darken it down just a little bit, and that looks good. So under parameters, let's take a look here. If I go back to the very start of the scene and turn on preview, we can see the difference between small and large where it places the tracks. Just makes a lot more sense when we set it to the feature scale to large. We can see these are all good tracking points as opposed to these points which are pretty much which are basically at a very bad spot. I doubt it could track that accurately at all. So we'll go with large feature scales with better accuracy. This will take a lot longer, but I think it's worth it. And I want some more tracks, and I want more targets, and I want to increase the window size, which is basically what it's going to be tracking. The larger that is, the more accurate, also the slower it will go. And because most of the movement in this scene is horizontal, I'm just going to lower the search range to 25 just to make this quicker, because that's the vertical search range. And these are all good, so let's go ahead and hit auto track, and this will take a little while, so I'll just let this go and I'll see you when it's done. Okay, that's finished, and I've also gone through and removed all the bad tracks. You'll know if they're bad because they don't stick. They'll be jittering around the place, and that's a little bit of a tedious task, just going through and simply clicking on the ones that are inaccurate and hitting delete on the keyboard twice. So once you've done that, I'm just going to add in some user features, just because towards the end here we sort of don't have a feature here. I'd sort of like a feature there, just to make it a bit more accurate. You don't have to, but I think it's a good idea. So I've actually just got that on the clipboard. I'll paste it in and then hook that up underneath the auto track. So I've got two trackers here, and when you're doing user tracks, make sure that they're hidden when they're not on the screen. So you can see here that tracker 02 is actually still on the screen even though it's not being tracked because it goes off the screen. So make sure that they're hidden when they're not on screen, and to do that we click on track 02, and this is the very last frame. So previously I want to hide it, and once that's done it will be disappeared. It will disappear from all previous frames, but as soon as it comes here it begins tracking and stays till the end. So once we've done all of those, I'm going to add in a camera solve, and I'm going to tell PFTrack that I know the focal length is 18.6. Again, you can find the focal length for your camera by using the estimate focal length, but I already know, which is cool. So with that done, we can pretty much just go ahead and solve these. Okay, here's our camera solve, and let's take a look at it in 3D space to sort of get a better idea of what's going on. And I'll just move this over. So we can sort of see we have our ground plane here, but it's not very accurate. This chessboard here actually isn't perfectly straight. It has a bow in the middle, but this ground plane is quite inaccurate, and I think what's causing that is PFTrack is weighting those two user tracks that I had too heavily. So what I might do is unsolve all, and actually that doesn't really unsolve it. I'm just going to add a new camera solver, and in this camera solver I will again tell it that I know the focal length is 18.6, but in the trackers I'm just going to take the hard weighting off both user tracks and solve again. So hopefully now in the 3D space we should have a much, they look a lot better. They actually look like they're part of a plane as opposed to before had some extreme outliers. And also what we can do is in the errors we can trim these. Don't put the threshold too low, otherwise we won't have enough trackers to solve accurately, but I'm going to keep it around here and then refine all. Okay, and that looks pretty good. These all look like they're part of the same plane, and the reason I'm not constraining them is again because this isn't actually perfectly straight, this checkerboard, so that would probably make it less accurate overall. So back in the one view, I'll just scrub through, and you can cache the whole thing to RAM if you want to play it back in real time, but I'm not going to do that. All bought, and let's orient our scene now. And basically the way I like to orient the scene is the exact same way you calculate the focal length, which is using the axes here. So let's take off these distracting elements, and let's just solo with the X, and basically I'm going to just tell PFTrack where the X-axis is. So 1 point here, another there, and 1 point here, another there. And we can see that the board isn't perfectly straight, but that's fine. And I'll just do the Z-axis as well. We won't really worry about the Y-axis because we don't have, we do have some things in the background that we could use, but once you do the X and Z, the Y-axis is not much. There really can't be too many angles it can be. Once you've done the X and Z, there's not too much leeway in where the Y-axis could be oriented, so it pretty much gives you the Y-axis for free if you've done the X and Z. So if I show the ground, show the ground, you'll see that we have the Y-axis pointing relatively straight up. And let's take off the edit mode to none and show our trackers again, and I'll just set the origin as this tracker here. Now we might want to rotate it a little bit this way, not too much because we'll be upsetting the this rotation as well. And yes, again, the reason these won't line up perfectly is just because the board isn't straight, and also other things such as the focal length isn't perfect, nor is the undistortion, of our barrel distortion. So this is looking pretty good though. It's very smooth, we have very low error, so we can now export this to Maya using the export node, wherever that is, and we want to use Maya 2011, and what we'll also want to do is not only just export the camera but the actual clip itself, because we've applied, we've undistorted the footage. We need to export this so that in the Maya scene we will be referencing this undistorted footage as opposed to the other raw footage. And also I'm going to undistort this PF barrel, which is pretty much just a node that you can use inside of Nuke to redistort the footage at the end of your compositing. So once you've done all those three, I'll see you in Maya. Okay, here's the scene in Maya. This is the default Maya project folder structure, and I've just created my own folder called footage, and here we have the undistorted footage from PFTrack. Under cameras we have the match moved camera and the PF barrel distortion node, And under source images, I've just added two images that we'll be needing. One is a high dynamic range image of the of this office that we can use for reflections, as well as a complete image of the chessboard. As you'll notice in the footage, the chessboard gets cut off. It's not all on the screen. We will be using this footage here to get some reflections into the scene, but obviously as it's cut off, that's not really going to be good enough for the chessboard. So let's first of all come in and add that chessboard into the scene, and we can do that just by creating an image plane here. I'm just going to make sure that it's actually square for now. If we go into the inputs, let's just make it 30 by 30, and if we scale it up, we will notice it's not going to sit exactly again because the chessboard isn't completely even. But let's just do our best, and if we hit 6, we can see that there. And under the hypershade, let's create a mental ray MAX passes, and with the 0 reflectivity, let's just add in a file node, turn the filtering off, make sure we tell Maya that it's an sRGB image, and under source images, let's use the chessboard, and let's assign that here. So we can see that the checker at the corner is actually the wrong one. So if we hit E, we can just, and if we press J, we can get discrete rotate, and we can make sure that we have the right checkers in the right place. And we could see that it sort of lines up here, but it's definitely not lining up here. If we hit W, then insert, and then press V, or hold down V, and middle mouse button, we can move the pivot point to that location. And then if we hit insert again, we can get out of pivot mode and just sort of scale the or manipulate this, just hitting spacebar and going to another view where we can sort of align this a little better. If we grab maybe this edge here and sort of push it up there, and it sort of looks like it's if we just go object mode and go transparent, we should be able to see, okay, that's looking okay. This plane here needs to come back a bit more. Doesn't have to be perfect. That'll probably be good enough. Okay, so once we've got that, let's just go and name this. This is our chessboard, and let's create the actual ground plane here, and that will just be another plane. This one will be larger, doesn't matter. We can make this one as large as we want it, really, and this will be our shadow catcher. And what we want to do is, if I just hide this for a second, we want to basically project the original footage onto the shadow catcher, so that the object that we have in our scene will catch the reflections from that, and also it will cast its shadow back onto the raw footage of the plate, as opposed to our chessboard plane that we just created. So if I turn both of these back on, let's go to the hypershade and create another MIA material X passes. No reflectivity again, and we'll be using a projection, and we'll be projecting an image, which will be a file, which will be our should be the same file as our image plane. It will be under footage, undistorted. Okay, so that's our original footage, and make sure that's sRGB and no filtering. If we just right click and graph network this, the projection needs to be from a camera, and that camera would be camera O or camera 01. I'm just going to rename that to render cam.